Hey, Ray, this is Mr. Roche. We are here with Python and Trinket and processing, and we're trying to deal with magnetism here so that we can use arc, cosine, and sine to determine like the angle between the two, puck and object. Okay, so we want to know this angle, and then we want to send the square off, in the direction sort of opposite of that angle. That's what we're doing. Okay. We talked about sine and cosine before, so let's actually just get to it and use it. Okay. So we'll use like arc cosine. Let's see. Let's call it like this: arc cosine num. Let's see. Yeah, let's call it like arc cosine, something like that. Okay. Or like arc cosine is going to equal, and then there's a function for this. It's a cos. Okay, and we're going to take the x distance and divide it by d, which we found. Okay, so what this is, we're trying to take, or actually we should do it for sine first. We're talking about that. We use sine and take the arc sine and do the x distance, which would be like actually the y distance divided by d. Okay. And what this does is it's going to give you something in something called radians, okay, which we talked about. So let's look at this. We can print this out and say the angle, or something like this, the arc sine in radians is equal to, I'll say string of arc sine. Okay, that's our thing. Okay, I can actually translate them to, I can get a degree from it. Okay, so I can go arc sine, like degrees, something like that, is going to equal the arc sine. Okay, if you multiply it times 180 and divide it by pi, okay, and pi in Python is just that. I'll do this, put this in parentheses. That should give me arc sine in degrees. Okay, so let's see what this looks like right now. Let's say arc sine in degrees equals string of arc sine degrees. Okay, so let's run this and see what we get. See if it's happy. It's not going to be happy because of that. Now it's going to be happy, hopefully. Oh, it doesn't know what this is. Okay, I think that's the thing. Okay, whoa. Okay, sorry, that comes from math. Okay, so let me see if it'll run now. There it is. It's happy. Okay, so what you're getting is you're getting these sort of like basically this should be a degree. Like, see, it's about 20. See how it's going down to like 6. It's going down to 0. It's negative. Okay, so I'm not sure we can deal with that, but that's okay. See how it's like 90 right now? It's getting to be 90. See how it's going down now? Okay, so you get these sort of values that you have to kind of deal with. Okay, I'm going to put it over here. So this is actually positive 90. So it goes like basically from, looks like, let's move it again. Let's run it again. So it goes like sort of negative up here. to 90, and then it goes down, and then it goes like positive to 90. So you get like, looks like this is sometimes because the Y flipped too. It's got it goes like this, okay, and it goes up to 90, and then it goes back down to 0, and then it goes to negative 90, and then it goes back down to 0. That's what's happening with that. Okay, interesting, right? Okay, let's try to do the exact same thing with the cosine one, okay? And what we'll do is we'll just do this. We'll copy these guys. So I need to kind of get these values, okay, first. So I'll call this our cosine. This is going to be our cosine. This is going to be the x distance. It's going to be cosine. Our cosine. And it does the exact same thing. And then we can just print this out again too. And we get like a cosine. Oops. Nice. Copy that. Put this in here. Boom. Turn these guys back on. Okay. So we'll say the arc's cosine. I'll say cosine here. Say cosine. And cosine. And then we'll look at this as well, okay? I'm gonna, let me save it. Refresh the screen, just gotta clear old errors out. Okay, I've got this stuff. I'm still in deal with magnetism, basically. I'm gonna run this. Okay, and I'm getting these cosine numbers. Let me pull this up so you can see it better. Whoa! Sorry. Okay. So you can see what's going on here if I can get this guy up here. Let's run it again. Okay, run it again. Okay. So the numbers you get here okay, that says it's 90 degrees. It goes down to 0. Okay, going down here it goes up to 90 here. And then it goes over here to 180. Okay, that's different. And then it goes down to, let me see if I get to 0. It's 0, but it doesn't go negative. I think that's what's sort of interesting here, is that this is going like this is sort of the same on either side. See this? Because the x is the same, right? But yet, let me see. Yeah, that's 90. Right? So it goes from 90 down to 0. Then it goes back up to 90. Okay, and then this goes to 180. And then it goes back up to 90. So they're a little bit different, and we have to kind of like deal with that. So what we want to do is we want to look at whether the distance, right, is within a certain amount. Like here, I think they should be working, right? So if the radius is between, so what we're going to look at, we're going to deal with this. We're going to say if the distance is less than, and what do I got? I got the radius of the circle, and I got the radius of the so if the distance is less than the radius of the circle plus the radius of the square, you know, plus maybe like, I don't know, say 5 or 10. Okay, so if it's like here, okay, that would be the radius of the circle plus the radius of the square plus a little bit amount. Okay, so we want that to happen. If that's true, then I want to do something. Okay, and here's what you got to do with this. Okay, so we've computed the arc cosine, and this is in radians. So we've computed the arc sine, and we're going to use them. Okay, and this is the thing. This is kind of what people do. So we'll say this, and what I'm going to do is I'm going to look to see if x center, if x center is greater than the circle center, meaning that the circle is sort of down here and the other guy's down here, right? Or if actually it's over here, then what I'm going to do is I'm going to do some step. I'm going to say the x speed of the square is going to equal, well, it's going to get minus. You're going to see minus equals a magnetism factor, okay, which we're going to make, times cosine of arc of the arc cosine. Okay, something like that. Otherwise, I want to do this. I want to add it. Okay, so I'll put it here. Okay, not bad, right? Okay, and what we're going to do is we're going to put in a magnetism factor. And make it be about, I don't know, let's see, maybe like I don't know, like something like 20, maybe like 18, something like that, okay? And let's save it. And let's try to run it. Let's see, and what it's going to do is it should do magnetism on the x-axis, is what we're really hoping here, okay? And hopefully there won't be any big errors and stuff, but whoa, he like blew away. I got an error. Let's see, x speed is. Oh, I have to do the globals thing. Let's see if that helps. Okay, so it's there. What I'm hoping is if we go here, it'll change x. There it goes. See it? So that's cool. And then I gotta make a new video here, but I'll try the second one too. Okay. Woo, that's cool. Oh, he's going backwards, so we have to deal with that, but it's okay. We can handle that. Okay. All right. So hang on there, and we'll be back in a second.